Hey everyone, and welcome to this explainer. Today, we're going to take something that, let's be honest, a lot of developers treat as just another annoying bureaucratic hurdle, the pull request, and we're going to see how to transform it into a vital, active immune system for your entire codebase. We're going to break down the professional PR lifecycle, literally from the moment you create a branch all the way to that final merge. Okay, to kick things off, let's talk about this massive number, $51,400. That is exactly what one company lost in a matter of just 4 hours and 12 minutes. No way, right? But why did it happen? Because of a single, catastrophic failure in their development workflow that slipped right through to production.
And get this, that devastating incident was caused by just 4 tiny lines of code. Literally, debug_bypass equals true. A developer left this little testing bypass in their code, self-merged it directly to the production branch without any peer review whatsoever, and boom, it deployed automatically. In an instant, free tier users suddenly had full enterprise access. And the crazy part, a single pull request with just one reviewer would have caught this in under 2 minutes.
So, let's use that massive failure as our turning point. We're going to hit the reset button and jump right into section 1, from branch to pull request, where we'll trace the correct chronological lifecycle to make sure an incident like this never, ever happens to you or your team.
Every pull request obviously starts with a branch. Now, depending on your project, you're probably using one of 2 main strategies here. First up is Git flow, which is highly structured, ideal if you're dealing with scheduled releases, strict compliance audits, and a generally low deployment frequency. On the flip side, we have trunk-based development. This is really the standard for SaaS models with those mature CI/CD pipelines, relying heavily on short-lived feature branches and hiding unfinished work right behind feature flags. Whichever foundation you choose, it totally dictates how your PR will eventually land.
But hey, regardless of your branching strategy, every successful piece of code has to travel this same structured path. Number 1, branch creation. Number 2, opening a draft PR. Number 3, the rigorous code review. And number 4, the final merge. Think of this as the chronological journey, the roadmap of our code's lifecycle.
Now here's a really interesting point. A pull request isn't actually fundamentally about pulling code at all. Really, it's a structured conversation. It gives us a diff viewer so we can see every single changed line, a discussion thread for actual human collaboration, and a gate for required checks. It's basically the single most important quality control mechanism we have in modern software delivery.
Opening a draft PR with a standard checklist template, that is your absolute first automated line of defense. By forcing the author to actually check off that yes, tests are added, no debug code or bypass flags are lingering around, and absolutely no hard-coded secrets exist, you catch those catastrophic mistakes before a reviewer even glances at the code. This is exactly the kind of thing that would have saved that $50,000 we talked about earlier.
All right, once the PR is marked ready, we move into section 2. The reviewer's security checklist. And reviewers, listen closely, because this is for you. Your job is not to just rubber stamp looks good to me and call it a day. You have to act as a rigorous, unforgiving safety net for the whole team.
A truly professional code review evaluates 5 critical areas. First, correctness. Does the code actually do what the PR claims it does? Second, security. Are there any glaring vulnerabilities? Third, tests. Are they really testing the behavior or just the implementation? Fourth, readability. Can someone else actually understand this in 6 months? And finally, design. Does this fit our existing patterns or is it just adding technical debt?
To really build that defensive barricade, there are a few very specific, security-focused questions every reviewer has to ask themselves during every single PR. Are there hard-coded secrets? Any debug flags accidentally left in? Is there overly permissive access? Are we logging sensitive data? Look, these questions are literally the dividing line between a simple, harmless mistake and a massive, headline-making production incident.
But finding a bug is really only half the job, right? The other half is how you communicate it. So let's look at section 3, constructive code review communication, where we're going to talk about the absolute necessity of psychological safety and having standard communication guidelines during that review phase.
Just look at the stark difference in these approaches. Toxic feedback, things like, this is wrong, or why did you do this? It instantly creates defensiveness. It literally teaches junior engineers to hide their work out of fear. On the other hand, professional, constructive feedback frames those same issues as open questions. Have you considered trying why? Or can you help me understand the reasoning here? It completely shifts the vibe, fostering true collaboration instead of immediate conflict.
Now let's be clear.
Being constructive definitely doesn't mean being passive. Here's a great example of how to firmly, but professionally, use the Request Changes feature. You are creating a hard block here to prevent accidental test code or hard-coded credentials from making it to the main branch. But notice how you're doing it by pointing directly to the issue without attacking the author. Requesting changes isn't a rejection, folks. It's just a necessary conversation.
Okay, but here is the harsh reality of software engineering. Individual human discipline is super fragile. Developers get tired, deadlines are looming, and yeah, people might try to just self-merge to get it done. And that brings us to Section 4, Enforcing Branch Protection Rules. We simply cannot rely solely on human diligence. We have to rely on our automated immune system to enforce these workflow rules.
You absolutely must set up branch protection rules. These physical barriers prevent unauthorized direct merges. You want to require at least one approval. You need to dismiss stale reviews the moment new commits are pushed, so nobody can approve a PR and then let the author quietly sneak in bad code right after. Require those status checks like CI tests and security scans to pass completely, and absolutely under no circumstances allow force pushes on the main branch. That merge button should literally be disabled until every single requirement is met.
And if you want to supercharge this protection, you need to use code owners. This is basically a file that acts like an automated traffic cop, routing PR reviews to specific people based on the exact file paths that were changed. So, if a PR touches billing or security code, code owners guarantees that the billing and security teams are automatically assigned as required reviewers. It just ensures the right expert eyes are always looking at the right code.
All right, fast forward a bit. All the checks have passed, the approvals are granted, and every single conversation thread is resolved. Let's jump into Section 5, Merging and Cleanup, which is the final stage of our lifecycle.
Now, a crucial checkpoint before you ever click that shiny merge button is ensuring PR size discipline. Research clearly shows that massive PRs inevitably lead to reviewers just skimming the code and missing bugs. Under 200 lines, that's ideal. Once you cross into the 400-line territory, you're definitely in the warning zone. And if it's over 800 lines, you absolutely must split that PR up before even requesting a review. It's simple. Smaller PRs equal much better reviews and way fewer incidents.
When it is finally time to hit merge, you've got to decide exactly how your branch is going to land on main. If you're doing trunk-based development, you generally want a squash merge. This condenses all your messy feature commits into one clean, super readable commit on main. But if you're using GitFlow, you'll likely use a merge commit instead, which preserves that full branch history and maintains those strict audit trails we talked about.
And finally, we have the cleanup. Step 1, merge the pull request. Step 2, delete your local branch immediately so it doesn't just sit there cluttering up your environment. And Step 3, clean up and pull the latest main branch. Doing this gives you a completely fresh workspace and helps maintain a really clear, searchable record of how the code base is evolving over time.
We've just seen how a single, easily skipped review can cost a company over $50,000 in just a few hours. The tools we covered today, those PR templates, reviewer checklists, code owners, and branch protection rules, they aren't just extra bureaucracy. They are literal survival mechanisms for your code. So I want to leave you with a quick, provocative thought. Is your team's immune system active right now? I highly recommend you check your repository settings today and implement these safeguards before your next catastrophic incident even has a chance to deploy. Thanks for joining me on this explainer, and I'll see you next time.